Welcome, everybody. You're listening to Structure Talk, a Structure Tech presentation. My name is not Bill Ulrich. This is Reuben Saltzman, alongside Tessa Murray and myself. We should be the three-legged stool, but we are not. We are short Bill today, but that's okay. We're going to try to carry the show because we do have a third leg today. Patrick Huelman. So excited to have him on the show, talking all things houses, home inspections, and anything else that's rattling around in our heads. Patrick, thank you so much for coming on the show. Patrick is a repeat guest. And I was just checking to see when we had you on last. I was thinking, it had to be several months ago. It's been a little while. No, it was right at the beginning of the pandemic. We had you on at the beginning of 2020. That's how much time flies. It just feels like yesterday.
Especially in the last 2 years, right? Yeah.
Oh my goodness.
It's a pleasure to be here. I enjoyed the last one and looking forward to this one.
Well, for anyone
excited to have you on, Pat. Yeah.
For anyone who doesn't know Pat, he is an associate professor at the University of Minnesota, and he was Tessa's professor back when Tessa was going to school at the U to be a building science professional. And so you guys have a long, rich history together. And Pat, you're always working on some super intriguing stuff. And we'd love to hear the latest stuff you're working on.
All righty. Well, yeah, sometimes it seems like it's the same old, but the reality is it does move on. Might seem old to me, but some of the stuff is fresh today for many. And
can I interject for a second real quick? For anyone that hasn't listened to our past podcast with you, can you also expand a little bit on just your background and what you've accomplished in your professional science career thus far and things that you're still working on today?
Sure. Yeah. So it goes way back. In fact, I was just having a chat over WhatsApp with my children, and they were talking about panels to go over the outside of your house to insulate your home. And we got into it a little further. And back in the 80s, late 70s, I developed an undergraduate degree that was in environmental design. So they were throwing out names of people that they'd seen on this old article. And one of the names was Victor Olgay. And Victor Olgay is the son of Victor Olgay, who developed a whole series of writings and books. He was an architectural professor in design with the climate. And passive solar became quite popular, and I was heavily engaged in that. That's what I developed my undergraduate degree around, and then continued that into my master's degree at Iowa State University in architectural studies. While interested in architecture, I'm not an architect just by how I was put together. I think more analytically. I think more like an engineer. I'm a problem solver, a different kind of problem solver. They solve problems too. I was heavily engaged in energy and energy efficiency. I worked at Iowa State University in the energy extension program. And then ultimately in 1980, I came to the University of Minnesota to work with the cold climate housing program. And again, I was still heavily involved in energy in my head, but it was becoming clear that some of the energy things we were doing were causing other issues: moisture and building durability, indoor air quality, concerns in some of our more energy efficient houses and other buildings. And very quickly, especially in even small as a trip that is from central Iowa to the Twin Cities, the climate was significantly colder enough that we saw much more of the moisture problems in these homes, both in indoors, humidity built up, or humidity that was causing condensation issues, or lack of proper moisture control causing building deterioration. So I was landing in the department at that time with forest products. And of course, a lot of our houses are built out of wood. So it really changed my focus quite a bit at that point into materials, wood in particular, and building durability, and picked up on the side more and more on indoor air quality as we were building better and tighter buildings. We had to pay more attention to the heating, ventilation, air conditioning. So that was kind of my history. I've worked in a lot of areas. I consider myself more of a building enclosure, the separation between the indoors and the outdoors, if you will, in our buildings. But I do have quite a bit of background in HVAC as well.
I was going to say, Pat, you're one of the most humble people I know, because you've been in this building science world for a long time, and I think you're one of the most brilliant minds in this industry, and you're well known across the country, and you speak nationally at all sorts of conferences, right? And didn't you just finish speaking at one? Was it called the National Home Performance Conference? It was in Nashville recently.
Yeah, the Home Performance Conference is an outgrowth of the Building Performance Organization, which previously had a number of names, but it started in probably in the 70s or late 80s as a conference called Affordable Comfort. And when we started, when we had the energy crisis of the 70s, we started thinking about making buildings more energy efficient. One of the areas that was particularly important was for low income homes, which were notoriously energy inefficient and with folks who couldn't afford to pay the bills. And so there was a lot of government effort into trying to weatherize these houses. And so that weatherization effort, which also created some of the same challenges that I mentioned earlier, while I was kind of focused a little bit more on new construction, was happening in our existing housing stock. And weatherization as a field has grown and grown and grown. And this conference has been annual, like I said, for decades, really focused on programs and program managers and field workers that are out trying to improve the energy efficiency, durability, and air quality of our older housing stock. So yeah, I did go down there. Interestingly enough, it was actually more of a new construction. Well, one of the talks was really more headed towards new construction, which they're embracing as well, along with organizations like EBA, Energy Environmental Building Association, who had started at a very similar time, tended to be more to new construction, and they're now blending over, or certainly going to retrofit. In relative to today's topic, one of the other presentation was on our project on how to retrofit, upgrade, insulate, and air seal, and all the good things we need to do for existing wall systems. So that was the second paper. It was really more oriented towards ventilation and managing building pressures in high performance, low load, airtight homes. But the second paper was really about retrofit of our existing housing stock, focused on walls and wall treatments that can be used on older homes.
And this is all part of the research you're doing with Department of Energy?
Yeah. So that project was funded by the Department of Energy through Pacific Northwest National Laboratories, and who we know well. And they realized and understood that we have probably one of the best facilities in the country for doing in-situ energy and moisture monitoring, at least, in a very cold climate, in our Cloquet Residential Research Facility near Cloquet, Minnesota. And so they brought us on board to do the experimental work. And then Oak Ridge National Laboratory was also involved in doing some of the moisture modeling work. So yes, this was quite a large team, quite a large project over almost more than 2 years, almost 3, to investigate these different wall systems. Very comprehensive and also challenging project that we tried to drive through COVID. But we finished up here about 6 months ago or a little more, and the report on that project will be out soon. But as I mentioned, we've done a couple of papers. I'll be doing another one in about 2 weeks for the Residential Building Design Construction Conference at Penn State.
So let me ask, I don't know a whole lot about what this entails. In my mind, I'm thinking today we can construct a 2x6 wall, and there's a bunch of fiberglass insulation that gets put in there, and probably a sheet of poly gets put on there. And you're trying to make something more energy efficient and more durable, and you're doing testing to see what works best. Is that a good summary of what this means?
Yeah, it is. And we're doing that in 2 ways. On the new construction side, we're looking actually at a building system that doesn't use any studs at all. That turns out to be far more efficient, far more durable, and super efficient, super tight building system that has less labor involved, et cetera. So that's kind of our new construction side. We call it the solid panel structural system. On the remodel side, we're trying to figure out, well, what are we going to do with houses that have 2x4 walls, maybe some plaster or old drywall on the inside and some type of lap siding on the outside? What can be done with those walls? So that's that 14 wall project, if you will, was really dedicated towards developing a base case wall where there's just empty 2x4 wall with old, pine board sheathing and building paper, tar paper, and clapboards. We used cedar siding, painted cedar siding, and an indoor that represented a heavy drywall or a light plaster coating. And we said, okay, that's the wall we have. What are we going to do to it? And we came up with 14 different strategies to improve the R value of that wall. Now, back to kind of your comment is, well, what is a wall and what do we need to do? And so whether it's a wall, roof, basement slab, it really doesn't, foundation system, doesn't matter. The building enclosure needs 4 control layers. The one most people are familiar with is insulation. We got to put something between indoors and outdoors to slow up the heat flow out in the winter and in the summer. That's our thermal control or heat control layer. I think most everybody appreciates we need an air control layer so we don't have air just blowing in and out. And so that's our second layer. We need to manage water, especially for building walls, roofs, other things that are well insulated and don't have a lot of airflow and or energy flow across them. If we get a water problem, we're dead in the water, so to speak. We're going to have a moisture buildup problem. We're going to have a lot of water that needs to get evaporated and dried out, and it doesn't have the energy or the airflow to do that. And now we end up with, basically mold first and then potentially deterioration of the wood, call it as it is, rot. Yep. So water control is remarkably important in all of our higher performing building enclosures. Like I said, older buildings didn't have it all the time, but they got by with it because they didn't have a lot of insulation and they weren't air sealed. And then the last one is vapor control. We need to slow the vapor flow down from inside to outside in the winter and outside to inside in the summer. That layer is not as critical actually as the other 3, but we can't forget it in very cold or very hot, humid climates. And so that leads to the 4 control layer. And when it comes back to kind of how we retrofit our existing houses, it takes us back to what I call the order matters. You don't insulate until you've air sealed, because just putting insulation in a leaky wall or roof or whatever is not going to make sense, right? And you don't insulate and air seal until you know you don't have a moisture problem, until you know your water is under control, right? So now we've got thermal, air, and water. And then we got to make sure that the building makes sense in terms of the vapor retarder function. So it might be poly. Kind of at this point in our building science field, we don't like poly that much. We like to find other ways to stop that vapor. But we do need an air barrier, and sometimes poly is the air barrier too. The point here is we got our layers now, but we have to do them in the right order. And that's where it gets really challenging on our existing homes.
Okay. And what are you finding when it comes to all these different ones? I mean, if you're going to be retrofitting a house, what are some of the biggest mistakes that people make? Let's say we're gonna gut this one room and then we're gonna put it all back together. You take out all the old insulation, if there was any at all, and you're gonna put the wall back together. What do people do wrong, and what's a better way to do it?
Well, there's several approaches, of course, for a wall. One is to work from the inside, just as you suggested on a gut rehab or remodel project from the inside. We could fill the cavity from the inside or outside without touching either one, perhaps, or we can work from the outside. So let's start with the one that you propose. What could go wrong here, right? We've got a beautiful cavity, and most of our buildings are, framed, light frame construction with a nice cavity there of some kind. It might only be 4 inches, as opposed to our newer homes today might have 6. Let's get some insulation there, right? Well, we don't insulate until we air seal, so we better have an idea how we're going to put an air barrier in the system to stop airflow across that cavity and across that insulation as well. And then we can put on a vapor retarder, and typically in a colder climate, that would be on the warm side. We can do that with our new interior finish, whatever that might be. We're in great shape, right?
Yeah, we're done, right?
Oh, well, right. But we forgot one control layer that's pretty important. What about the water control layer? What if the existing wall actually leaks a little water? What if the windows that are in that existing wall leak a little water? What if the penetrations that go through that wall for, your dryer vent or this or that or whatever leaks a little water? What if the cable guy was there and just drilled holes anywhere he wanted to through that building enclosure to get cable TV in the home somewhere? That's now a water leak, potentially. They don't do a really good job of sealing it up typically. So now we've insulated, air sealed, and provide vapor protection on a wall that's not water managed. That's going to be disastrous, right? It only is going to take 1 leak or 2 or 3, or maybe a leak this year, another one next year, another. And pretty soon that wall's either full of mold and or potentially leading towards deterioration or rot. So that's the real critical piece, is you have to be able to assess how good your water management is. And for a lot of our older homes, like I said, it isn't perfect, but they get by with it. And if we fill it full of insulation and air seal it, we have taken away the energy needed to dry that water. We've taken away in some cases, the drying direction or drying capacity through air and or vapor to quickly dry it out. So that's the challenge, I think. And, so we could counter that and say, well, what if I just fill the cavity full of insulation? We've seen a lot of that, right? Fill it full of cellulose, fill it full of fiberglass from the outside or inside without removing either surface. Okay, so now we have thermal insulation. Did we get an airtight air seal? Maybe, maybe not. Perhaps not if it shrinks a little bit and moves around. Did we change our vapor condition? Probably not, but you could with a vapor paint. But many older homes, quite frankly, have so many layers of paint on the inside and so many layers on the outside. They have a vapor retarder on both sides at this point in their life. So now we have vapor protection in a way, but that's also means we don't have vapor drying. And we did nothing with the water management again. So we're seeing, and what I'm leading towards, my bias is pretty clear here, is that I'd rather see people slide to the outside where now we have an opportunity to get a very good water control layer of some kind. We can provide the air seal from the outer side potentially, and we can add insulation either into the cavity before we refinish the outside, or we can just simply add it to the outside. So that really was the crux of this project. Was we had some that had cavity fill only. We had some that had cavity fill plus exterior. We had some that had exterior only. And we actually had one wall that goes all the way back to your original question. And well, what if I was working from the inside? Could I put some in the cavity and then some insulation on the inside and then my drywall? Get a little more R value, a little better air tightness, a little bit vapor control? Absolutely. So yeah, we did all the above.
Pat, how many houses could this research impact? Like how many houses in the United States just have very little insulation in the exterior walls?
Boy, that's a great question. And it's in our report. I don't know that I recall off the top of my head, but it's a lot more than you might think. So when we started this project, PNL with help from NREL, National Renewable Energy Laboratory, that has a database, if you will, of kind of what's called residential stock, res stock, what does our existing home stock look like? They have a lot of detail there. And so they went through that just to see, and insulation obviously is going to give us the best payback in colder climates. So they looked across the cold climates, and remarkably, more than half the walls of these older homes are still empty or literally, have very, very little. Minnesota was slightly different. We are better than half of our older homes, or half our homes have insulation. And I think they were just looking at older homes like pre-70 or pre-80. I don't remember the number, but we're a little better insulated than some of the other northern climates. But that represents a lot of houses. And the other part of it is some of our houses maybe get insulation in the wrong way. It might need to go back and revisit the insulation, even though it's been added. Maybe it wasn't done properly. So it's a lot of houses across the northern part of the country for sure.
So a lot of these houses could improve their energy efficiency, and you've got some ideas of ways to do that. But one thing that's interesting about building science is it's risk assessment. It's like, if we do it this way, what kind of potential problems could this cause? And you've got hopefully some recommendations for people out there based off this most recent research that you've done with these 14 different wall setups. Is that correct?
Yeah, to a certain extent, yes. Maybe the cautionary notes aren't as obvious or as numerous as we perhaps should have, but we certainly reported on how these walls behave, both energy-wise and moisture-wise. And so the project was set up basically, the experimental part, or the in-situ part that we did, where we're actually measuring heat flow through the wall, we're measuring temperatures at all the different layers, we're measuring the moisture content of the materials, we're measuring the RH at various points throughout the wall. So we were doing a very detailed job of measuring these walls that we actually constructed. Now they're small ones, and there's small panels, if you will, 4x7 panels that go up in an opening in the building, but then they get fully monitored. And they're monitored for a winter. The one set of walls were actually monitored for 2 winters. But the point here is we were doing some detailed measurement. So that information, because not everybody in the country, lives in Cloquet, Minnesota, right? So by using those detailed measurements, feeding that to Oak Ridge National Laboratory, they could then go in and run Cloquet weather data, just like what we gave them, and run our results and get that all synced up. Then they could say, well, I think our model is pretty accurately reflecting what's going on there. Now we can plug in other people's climate data.
Climates.
And then that would then see how it would work elsewhere. So they were able to kind of spread the results of our work across a lot of climate zones that weren't in fact measured. And so that was also done for the energy part. Pacific Northwest National Laboratory did the energy modeling in a very similar way. Yeah, that's really was the intent, was to try to get it to be as global as possible. So the results are there. Are all the caveats there? Well, maybe not totally, but I would go back to this idea of when the order matters. One of the things that we do highlight in there for certain is that if you're going to upgrade the building enclosure, remember, you don't insulate until you air seal, and you don't insulate and air seal until you have proper water management, and you don't do any of those until you've got your inside act together, meaning you have good combustion safety, you have good ventilation, and decent, performing equipment. So that's another little hiccup here, right? We can't go take on this problem until we make sure we've got some other things in place inside. And then that's clearly in there. And then it does show the differences in these walls in terms of moisture response. So that, to me, that's good. And we found that the classic, cheapest way to do it is to pump in cellulose, dense packed cellulose, or a high density fiberglass fill. They both worked reasonably well, but they're also a little risky in the cold climate and in a hot, humid climate because of lack of good vapor control. And if you don't have good water control, they would be even riskier. That's the challenge with this study and results is this is sitting in a building with a 2.5 foot overhang, 1 story. It's not getting, water dumped on it in a, copious fashion. And we did do some monitoring in the summer, but it was really focused on kind of the winter behavior. So there are some, like I said, there's some caveats to the study. And, but I go back to, let's get get things in order. And if we don't have good water management, we have to start there.
Now, I got to ask you real quick. You've used a word a couple of times, and we transcribe all of our podcasts for anybody who's hearing impaired so they can get this content. There's a word you've used a few times, in situ. Can you just explain what that word means?
In situ, in kind of real time and in a real climate environment. So as opposed to a laboratory where we might have a wall and we change the conditions on both sides, we're doing it in situ in cloquet, meaning that we're going to take the environment, whatever it gives us on the outside. We do manage the indoor condition in terms of temperature and humidity. So, and like I said, it's in real time and kind of in a real typical service condition, if you will.
Okay.
So, all right. Pat, going back to the research then, kind of showing that blowing in like a dense packed cellulose or a fiberglass in exterior walls in existing homes is what you found to be, it sounds like, a pretty good option. Now, it always depends, right, on the house and the environment and all these different things, water management, how risky it's going to be. But, can you say like how much in general the average savings would be for someone who went from like zero insulation in the walls to doing this strategy? Like, how do you sell this to your average homeowner out there?
Yeah, I mean, that's really critical. I'll just start by saying most people overemphasize the amount of energy they're losing through the walls compared to some of the other things in their home, right? But in these cases, if you were insulating sufficiently, and we're saying kind of hit current code levels or above, and you manage to get the air tightness in place, we're talking in the range of 20 to 40% of savings. Again, that's going to, what that translates to in terms of dollars and cents is obviously going to depend a lot on the efficiency of your heating equipment. It's going to depend a lot on what kind of heating fuel you're using and those things. But those were numbers that were, achievable. And like I said, in some cases, we had significant amount of insulation. I think we had some where what I'll call the real whole wall R value, not just the insulation R value, but the actual R value across the entire wall with the framing and all. We're probably pushing R30. Many of them were closer to R20, 25. And then, the dense packed fill with, 3.5 inches only, those didn't quite get to 20. So they were closer to the 15 mark.
So 20 to 30% savings on your overall energy bill, typically. Yeah. And this is going a little off topic, but what's the biggest bang for your buck if you're a homeowner in an old house? Like, where should you start?
And you don't want to tear your walls off.
Yeah. Right.
Well, good. And really, quite frankly, it kind of goes back to this when the order matters, right? So I would encourage people, and most people have come up with this too, and, supported by many others, is well, let's just get the highest efficiency equipment we can in the home. That means that whatever the losses are being met as efficiently as possible and using as the least amount of fuel as possible to meet those loads that you haven't managed yet. But the second course is that most of that's going to be, sealed combustion equipment, where now you've improved your combustion safety part. And that should always be the first priority in any home anyway.
And let me just clarify, when you say sealed combustion equipment, you're talking about a high efficiency direct vent furnace. It's going to have two pipes. One takes fresh air in, mixes it with fuel, and then the other takes that exhaust gas back out. And what people see on the outside of their house to know they have that is two PVC pipes sticking out. And in the winter, you have a bunch of, looks like steam coming out of one of them.
Mhm.
That's what you're talking about when you say
Yeah,
sealed
absolutely.
combustion.
Yeah, absolutely. The combustion chamber sits inside your home, but it doesn't know it's in your home, right? It's seeing the two pipes, the one with bringing in air and the one that's exhausting the air, and typically with a fan or some type of power to ensure that those combustion byproducts are going out that steam event like it should. So to me, that's a priority in any older home anyway. And it helps your efficiency tremendously.
Now, I just want to touch on this while you're bringing it up. If you've got an older home, a really inefficient furnace, you've got something that's constantly changing out the air in your house. You've always got household air coming in, being used for combustion. Not only that, you've got the dilution air going up the draft hood all the time, constantly changing out the air in your home. And you get somebody who comes in and they swap out their old 80% or less efficient furnace and they put in the high efficiency. All of a sudden, you don't have those air changes. That's certainly something you're thinking about at the same time, right?
Oh, absolutely. Yeah. So in addition to being able to generate heat for the home more efficiently with less fuel, you are going to change the air infiltration, the effective air infiltration rate of the home, because again, those older furnaces are using house air and that has to be replaced by outdoor air. So you'll drop your air leakage, if you will, back a bit. That can be a good thing, obviously, from an energy efficiency perspective, but you might notice that moisture is hanging around a little longer. Some homes, that's not all bad. So they get too dry. Some homes, that's going to push the envelope, so to speak, a little bit. So yeah, you have to watch for that. And quite frankly, it's changing the pressure regime in the house, right? The old one was using all this house air, creating a negative pressure and going up the chimney. That brought outside air through the wall, dried it out. Well, now we're going to change the pressure regime because we're not using that house air any longer. So the house is going to operate a little differently. Except so the inside might see more moisture. We might see more moisture leaving the top side of the building than it did in the past. And that could add to condensation in the attic or condensation in the wall, upper wall cavities. Or it's not uncommon to drive by houses where there's, frost or fog, between the primary window and the outside storm on the second floor. Another example of air leaving the building up above and leaving some moisture behind. So yeah, there are some cautionary notes with that, of course, but you want to get your combustion safe. You don't want to have to worry about whether it's going up the chimney properly or not. And so the second thing that comes right after combustion safety is ventilation. You want to have good safe combustion. You want to have good outdoor, good fresh air coming in the home. So, a lot of people always say, well, build tight, ventilate right. And I try to turn that around and say, no, ventilate right. Then you can build tight, or you can start to tighten up the building without worrying about it, right? So I like people to get that ventilation in order. And maybe it's not a fancy, fully ducted, heat recovery ventilator, energy recovery ventilator, something like that. Maybe, some simple ventilation strategies that make sure you're getting fresh air in your home. And making sure that fresh air is getting throughout the house. Another issue that I've worked a lot on when I go over in the HVAC side of things, heating, ventilation, and air conditioning, is I worry about distribution of fresh air. So the reality is the average lifespan for a person is about 79 years. 26 of those years, you will be breathing your pillow. You're going to be in your bedroom. And so I say to people, why wouldn't you want good quality air in your bedroom? Now, remember, many of you probably can think back years and years ago to your parents, your grandparents that actually cracked the bedroom window when they went to bed. How many of us do that today? Well, hardly anyone, right? And especially if you're worried about energy, you certainly wouldn't open the window, right?
Yeah.
So the whole point here is get your combustion in order at a very high efficiency level, then provide some strategic ventilation. And now you're in great shape, right? Now you get to go attack the enclosure. Now you go for the low hanging fruit. You seal the air leaks that you can seal. You can put on, window, plastic film on the window and tighten that up if that's one of your big leaks. And that also improves the thermal performance of the window too. And then you can start attacking some things without worrying. Oh, geez, my furnace is still going to be safe. And, do I have enough ventilation? And we shouldn't be relying on random leaks to provide ventilation anyway. But all it does is it allows you to move on. And then you get the point, well, should I add some insulation here? Should I add some insulation here? Right. So now we're back in the order, combustion safety, ventilation, assuming we get proper water management. That's the next piece before we touch that enclosure, and then insulate and air seal and insulate. So yeah, I like, let's take the low hanging fruit where we can on the inside and get our house in order, so to speak, before we tackle maybe the wall insulation, because it's going to be expensive. And really, to Tessa's point here is, how do you decide what's cost effective? And we're really getting challenged by that right now, because we have, of the 14 walls, we have some that are relatively inexpensive, like the what we call drill and fill cellulose or fiberglass, $2-3 a square foot. They pay back relatively quickly, less than 10 years. Yeah, and if you don't have a water problem, you've got good water management, a few other things going for you, you aren't going to cause any significant or severe moisture problem, that doesn't look too bad. But what we found is, well, then it's going to be really hard to justify the next level of insulation. So now you're kind of trapped at 15. And when you go add another 15, let's say, to the outside, it's going to take forever to pay back, because you've already, kind of, took the low hanging fruit and ate it. Yeah. And so that's a real challenge, is trying to figure out, well, DOE wants our values that are much higher. We're thinking about, global climate change and emissions and now decarbonization and all these issues. Maybe that's too little. Maybe we shouldn't be stopping there. Now, from a homeowner's perspective, they go, yeah, I got most of what, I got the big bang for my buck, but that may be too little for what we want for the future of that housing stock and for our planet. So that's kind of a challenge now, is how can we go further and still keep it cost effective?
So that extra 15, that R15 you're talking about putting on the outside, it's not as cost effective as the drill and fill, because you literally have to remove all of the siding, right? And weather resistant barrier, if it's there, install this, I'm assuming some type of rigid insulation, and then put it all back together. Is that what it looks like?
Well, in some cases, we had walls where we were trying to leave the existing siding in place to avoid that cost. And let's say the siding is, has lead paint on it. Let's say it might be even asbestos type siding, yeah. Right? So we were looking at some of these treatments to leave the siding in place as well. So let's just back that outside off a little bit, but we had one wall that used a vacuum insulated panel. It's a vacuum panel that has basically a vacuum in it. That means that there's no gas conduction. Everything has to be by radiation, but it has a series of radiative barriers in the panel itself. So about a 3/4 inch, almost 1 inch panel gives you effectively an R 15 to 20.
Wow.
Now, the issue is there's still joints and seams and things that have to happen as that panel gets put together, because you can't put fasteners through it or you ruin the evacuated panel, right? So in the end, let's just say when you get done, it's about an R10. Now, this product we tested came with a vinyl siding kind of already attached, and you just clipped it together and went up the wall just like you put on vinyl siding. And it gives you effectively an R10. Okay, so we're going over an empty wall. R10's nice, but that's not probably where we want to be today, right? So why not drill a hole in the siding and sheathing, pump it full of insulation, and then put the new siding on, right? And then you don't have to worry about the holes. That all made sense. But the point is, well, the cavity does such a good job, it was kind of hard to justify the 10 high cost vacuum panel.
Right.
So that's that trade-off where we're sitting here going, well, I could have done that. That's pretty expensive. It had some good payback, but this cavity would have had better payback. But once I had the cavity, then it took the payback away from the outside layer. So we looked at other less expensive outside layers, just things like semi-rigid fiberglass, rock wool, expanded polystyrene, EPS, extruded polystyrene, XPS, graphite impregnated expanded polystyrene. So we looked at a lot of the kind of extra insulations that we could. Polyurethane foam was another one. the company produced these 4-inch blocks that have a vinyl siding already on them. And you simply just build it up like Lego blocks on the outside of your house. Worked really, really well. Very slick, very easy. Not particularly cheap yet, but that's another approach, right? And that could get you, an easy R20 plus with just 4 inches. So lots of choices, lots of things to think about. And again, from a homeowner perspective, the good news is a lot of these exterior treatments, you can be in the home and stay there, don't have to leave. That's nice. It is a good opportunity to get your windows resealed if you got the right techniques to do that. Put in new windows at the same time, do the siding and insulation/siding. So, again, in the end, there was no clear-cut winner, so to speak, because it depends a lot on the house that you have and what you want to accomplish.
No, I want to ask, you talked about just doing what you can with the existing setup. Start with that. You talked on heating systems. What do you say about cooling the house? I mean, is it just go with the highest SEER air conditioner that you can find? What do you recommend there?
That's a great question, because cooling energy, is expensive, right? We're using electricity, and it tends to be expensive. And more people are cooling more of their home or longer periods of time. The outside environment has certainly warmed up a bit in the summer here in Minnesota, and the dew points have certainly been elevated. So there's a lot more cooling demand. And so, and more interest, or occupants just less willing to put up with without air conditioning. So that sector is growing quickly, and it is significant in terms of cost. The flip side of that is the building enclosure, and let's say the walls, are not the massive culprit in cooling. In cooling, it's the windows, the solar gain through the windows. It's all the internal gains in the house, the lights, the appliances, the people, all the things that are producing heat in the home. It also is the air from outdoors, whether it's unintentional or intentional, that warm air coming in with humidity in it plays a big role. So, a lot of people think, well, if I do this for heating and I get 20 or 30% savings, then I should get 20 or 30% savings on my cooling immediately. And you don't, because the wall just represents heat coming through the wall represents a much smaller percentage of the cooling load.
Okay. All right. Makes sense.
Pat, do you still have to worry about condensation forming inside the wall cavity when you're adding on this exterior insulation on these retrofit systems?
Well, great question. And really that's why another reason I have a bias towards the exterior. As you move towards exterior insulation, let's say the point that we're concerned about condensation, and typically that's going to be the sheathing, whether it's the old sheathing or a new one, but typically we try to keep the old sheathing in place, gets warmer and warmer and warmer, right? As we insulate to the outside, that keeps that surface much warmer and much less likely to have condensation. And that means we can get by with a little less concern for the inner vapor retard, or a little less concern for the inner air barrier. And we can, in fact, then put the vapor retarder, if we think we need an additional vapor retarder for that additional insulation we're putting, we can put that on, onto the outside, so to speak, or the first layer to the outboard side, and then that'll give us our water control air, perhaps. That'll give us a vapor retarder if we choose, and it'll give us air tightness. And then we insulate beyond that. And so that really starts to bring in this concept that we refer to as the perfect wall. And the perfect wall is just a term that's been coined by Joe Stieberk of Building Science Corporation. He doesn't take any credit for the concept. He just kind of made it popular to call it the perfect wall. And I always remind people, that doesn't mean that it's a flawless wall or it's going to work perfectly all the time. It's a concept. And the concept's really simple. You put the structure on the inboard side of your control layers where it'll always be warm and dry. And you put your control layers, heat, water, air, vapor, to the outboard side. And then typically we like to put a cladding on that will also drain and dry. So if any moisture loading from the outside gets past the cladding, and it gets past all of them at some point, it can easily drain and dry without putting additional load on the cladding system, the siding or whatever, or on the wall itself. And so this is a very simple, structure, control layers, cladding that drains and dries. Such a clean, easy concept, and it works everywhere, works all climates. It's just amazing, but it's expensive and it's different, right? It's putting all that effort and energy and money, outboard of your existing structure, if it's an existing home. And so again, that's why I have this exterior bias is let's get out there where we control the water, because our older cladding systems simply weren't, they do a decent job of shedding, but there's just too many opportunities for water to get around that. Like we all know, window leaks and things. And it gives us an opportunity to kind of flip the house to this idea of a perfect wall or perfect enclosure concept, where that existing wall now, even if it had been stressed or strained a little in the past, is now going to be warm and dry. And we've essentially taken that wall and moved it indoors, where it's a much better condition from an energy and moisture perspective.
You know, for people that are listening, they might say, like, sounds crazy to be building a wall that doesn't have cavities or doesn't have studs. Like, how they can't even envision this. And what's fascinating is you guys have already built these houses and you've tested them, right?
Yeah, absolutely. Yeah, many of them. Yeah, there's dozens basically in the Twin Cities, either done with our projects or with our direction and guidance. And then a previous inventor had a different system that was built in the 90s, late 90s even. A similar concept, not exactly the same. But we know we can do this. And basically you're using, instead of using studs, so like when you're building something strong, right? And you put up a bunch of studs, we'll call them toothpicks, right? Mm-hmm. You can build your toothpicks, but they're not very strong really, right? They can kind of twist and turn or push and this and that. So we use toothpicks with sheathing that stiffens up the toothpicks in basically all three directions, at least two-dimensionally anyway. And so that's what we've built with forever. And that left us a cavity. And we thought, well, as long as we got a cavity, you might as well insulate it, whatever. And then we had to put vapor control and air control and water control around it. But what we're looking at is basically a plate type design where there isn't these studs and light framing elements. We simply are going to a super thick sheathing that acts as a plate in all directions and can hold the load and take the wind load and take the shear load, all with this thick plate. And then that plate becomes the house structure. And those plates can come in very large. We bring in 8-foot by 24-foot panels and swing them around and get them in place and tie that plate together. And then we go to the outside and put a peel and stick membrane that's air, water, and vapor tight, and then some insulation with a furring strip on it and cladding, and you're done. Water and vapor barrier or film membrane gets tied into our windows, of course, and all of our openings. So everything's airtight, watertight.
How long do you think it's going to take our building industry to catch up to this science, Pat, to start building houses this way?
Yeah, well, I think it's going to take a while to get the plate in there. Right now, we're doing research on the structural aspect of the plate, what we call the SPS, solid panel structure. And the results are really good. I mean, so there's a lot of reticence, like, well, I don't know if I understand the science really, but even if I understood the science, I'm not sure if I trust those OSB panels and blah, 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 right? Now, of course, we're seeing in the rest of the market, multifamily and commercial, everybody's, just going wild about CLT, composite, cross-laminated timber, because, as a structure. And this is just a lightweight form of that with composite rather than solid wood. But anyway, point here is that there's still a lot of reticence to think of that as structure. And with the tests we're getting, that's going to help overcome a lot of that. I think it's still going to take a long time till we can get a panel-like wall system accepted in residential construction. We have tilt-up panels in commercial and warehouse and multifamily large buildings, right? I mean, we know how to build these plates. Almost all commercial buildings have floor diaphragms or floor plates that act like plates in concrete generally, but now CLT potentially. So I think the world's going to finally realize that plates work. And so we'll see a little bit of it slide in. I just don't know how fast it's going to go. But the bottom line for me is you don't have to wait for that. Just build a 2x4 wall that everybody trusts and has for a century or better, right? Build a 2x4 wall to hold up your roof, get your sheathing on it, put on an exterior air, water, vapor retarder, thermal insulation, furring strips, and cladding. And so there's nothing stopping us from adopting the perfect wall right now. And if you do this right, you can actually put some insulation in the cavity. Now we call it a hybrid perfect wall, and it still works. And it works marvelous. And you can get tremendously good R values. And, you're still building in the old-fashioned way with this kind of exterior component. Partly why we want to go to the plate is we know the exterior is expensive. That's what drove us there. These exterior control layers are expensive. And what we want to do is come up with a simpler structure that's cheaper to buy the materials and uses a lot less labor. So we can take that savings, capture that savings, and put it into better control errors and a more durable, resilient building enclosure.
Existing housing stock has a long ways to go, doesn't it, Pat? I mean,
Yeah, it does.
I mean,
Here's the final twist, though, right? That exact same technology, and we're working on this right now with what we call an overcoat panel, will actually come out looking very, very similar to what I just suggested. You'll come out and you'll just hang it on the outside of your existing home, and integrate with your windows and penetrations, of course, and you're done. So
wow,
it's weird how you can kind of come around the whole circle, right? And it's not cheap yet, it's not available yet, but there's hope.
wow, fascinating.
So if somebody is ready to redo their house, they want more insulation, they're living in a really old house, they've got uninsulated walls, where would you tell them to go to start getting a good professional who knows about all this and can give them the right direction and get it done right?
Well, that's a challenge. I think we've got to have really sharp folks that can help us, as Tessa suggested, do the risk management. If I had an older home, the first thing I'm going to look for is how good a job is it at managing water? Do I see evidence of water intrusion? Do I see evidence of mold growth or deterioration? And those things would cause me to pause and say, that's not a candidate for insulating the cavity. That's not a candidate, maybe even for insulating from the inside, because we haven't managed the water. So getting professionals such as yourselves and other building science professionals that can come out and essentially just do an envelope assessment. And we don't worry about the air tightness per se. We should do a blower door and find out things and get to know some things about that house, but we can fix that, right? It's the water control that's hard to fix on that with the existing cladding system in play and windows set in play, right? And if we can't have confidence and comfort that we're going to stop the water from getting into the cavity, then we shouldn't be insulating and air sealing the cavity. So that, to me, that's the professional judgment that has to come into play.
I think you point out, there's a big hole in this industry, like Reuben. Who does a homeowner go to try and upgrade the energy efficiency of their house without creating more unintended consequences? And the answer is, I don't know. Someone who understands the house, understands all these pieces. You call them out to assess insulation in the wall, but really they need to understand how water management works and how their house is being ventilated. Who does that? It's really who understands the house holistically. And sometimes you can find insulation contractors who understand building performance. Sometimes you can find builders who understand building performance. Sometimes you have, energy consultants who get it, or even home inspectors like us who understand it. But I wish there was a clear-cut answer to your question, Reuben. I don't know if there really is an easy answer.
So just if you want better energy efficiency, focus on your furnace. That's what I'm hearing.
Well, yeah, it's a pretty sure way to get efficiency and combustion safety. Yeah, exactly. And puts minimal risk other than that issue we talked about before, where it
moisture
reduces your air exchange rate effectively in your house. Yeah, it's a pretty low risk way to get improvement. I think what's going to happen, I hope. So you're right, Tessa, a siding contractor could come out and sell you this vacuum insulated panel siding. I can put it up tomorrow, right?
Yeah.
Here's what it costs. But they aren't thinking about combustion safety and ventilation and water management. You could put a WRB, whether it's just a barrier behind it, and then, okay, so now I got my water in control. That's fine. That's good. But they're just seeing one part of it. And same thing with, people who do the drill and fill in the cavity. They're not looking at all the rest. They're not looking at the water management. They're not looking at the inside part of it.
They're not looking at the knob and tube in the wall.
Yeah, the knob and tube wiring. Exactly. So, I'd like to believe, this group that I'd call the building performance consultant plays that middle role. So the remodeler can't know everything, right? Mm-hmm. The homeowner certainly isn't going to know everything. So the homeowner contacts the remodeler, but the remodeler is smart enough to bring along a building performance consultant to do some of that assessment. And they aren't going to see everything and know everything. Everybody's done a remodeling project where you had surprises. That's just the way it is. But they can reduce the surprises, reduce the risk, and perhaps guide them as, I think in this case, this would be a safer direction, or that'd be a safer direction. And then the remodeler has to pull together his trades that can actually effectuate or deliver that in a high performance way.
Yeah.
So start with your furnace.
That's what I'm hearing.
And then if you get a little ventilation, you can air seal with some comfort that you aren't messing things up, right?
Yeah.
Ventilation and air sealing. That's always a good place to start. Air sealing and insulating your attic too.
Yeah, attic's pretty safe. You want somebody that knows what they're doing up there. You'd like to air seal the attic before you insulate it. You'd like to have proper ventilation up there, which makes it a little more robust, a little more durable,
Right.
resilient. So yeah, that's a fairly safe one, and for most homes, many homes.
Excellent.
Houses are complicated, aren't they?
They are, yeah. And like I said, you need the advisor. I just wished I knew where and how that existed in a easier way, right? I mean, so if you have your car's light comes on, or it's just not, it's running rough and not acting right, what do you do this day and age? You take it to a mechanic that plugs it in, runs the diagnostics, and says, here's the 3 things we found. Could be something else too, but here's where we'd start. If you want to have a financial plan for, your future, your retirement, for your kids, whatever, you're going to do that on your own, or are you going to go get a financial planner that says, hey, here's where I'm at. Here's what I'd want to be. Here's what we think we can do to get there, and guide you. But when it comes to our houses, it isn't a simple phone call.
Yeah, very true. Well, Pat, we can't thank you enough for all of your time today. Such a pleasure to have you on the show. We got to do this more often than once every 2 years. We'll have to get a date on the calendar as soon as we're done with this show. But
I thoroughly enjoy it. No, this is fun. And like I said, anything we can do to kind of spread the word and get people thinking maybe in slightly different direction, slightly safer and better direction, that's always good.
Well, thanks for sharing some of the research too. And maybe we can even, once that paper gets published, we can link that in the show notes too.
Yeah, I expect that to be out here pretty soon.
Okay, cool.
Awesome. Well, thanks again for coming on the show. I'll sign off for Bill here. This is Reuben Saltzman and Tessa Murray for Bill Ulrich saying mahalo.
For more information on how we can provide you with the right information about your home before you buy or sell, contact us at structuretech.com.